Thank you very much, Olivier, and welcome. Good morning to everybody. Thank you very much for your assistance, attendance. This is Josep Portabella. I'm working in Fractus Antennas as a General Manager for Europe, Middle East, and Africa. And we are going to present our range of services to help you to integrate a chip antenna in your devices. We have structured this presentation with a little introduction. I will go through the products and technology we have in virtual antenna, and then we will specify and we explain what services we are offering to our customers to integrate the antenna in an easy way in their device. Wow, I don't know what happened today with this. Let's see. Okay, just a little introduction for you. Why is the antenna important in any IoT device? It's because we have to communicate between the edge and the cloud, and we are facilitating, and vice versa, of course, and we are facilitating this communication. Of course, the cost of this massive IoT communication is seriously impacted by the range of the radio in the antenna and the longevity of the battery. So they are both. In some cases, it's a trade-off because the better is the range of the antenna, the longest will be the battery. In any case, what is important, and I will emphasize it in all the presentation, is the antenna performance to reduce cost in your device. And here is the most important thing. In this technology, it is important to understand that the antenna has to be the first element to be located in the new design, in the PCB. Otherwise, if we are doing it in the old way of making the design, that the people are focused on the microprocessor, the battery, and other elements, cables, passive connectors, whatever, and at the end, they put the antenna. You can understand that the performance of the antenna will be impacted by this location of the antenna at the end of the design. It must be at the beginning. And this is what I explained in this important slide to recommend you to follow this path when you are working with chip antennas, and in this case, a virtual antenna. So in order to maximize the performance of the antenna in the device, the antenna needs to be located first. As you can see here in this picture, the PCB is already prepared with ground plane, clearance area, and the antenna first. We are going to give you, in one of the services, these recommendations, how to locate and place the antenna to maximize the performance. After that, you can start to make the Gerbers, and you can locate all other components around the PCB in both sizes without impacting or minimizing the impact in the antenna performance. You can send to us these Gerbers, and we make a sanity check, and finally you can make a prototype. Don't do the other way around, because I have many customers saying, I make a prototype and your antenna is not working well. So we are inviting you to follow this design path before to spend any time, any money in producing a prototype. We are going to help you to make some feasibility analysis of the project with the integration of the antenna and estimation of the performance in your PCB. And if you are satisfied with it, then you can make the prototypes. So don't follow the old way of making the design. I make a prototype, I test the antenna. If the antenna is not working, then after 2 or 3 months, you are discovering that this is what you're not expecting. Then you have waste time and money. In this case, we are offering to you the possibility to make the feasibility analysis of your project, I repeat it, before to make any prototype. We are going to present these tools to do it, okay? I will come back to this slide, but keep it in mind that this is the recommended path in the design, okay? First the antenna, after the components, sanity check in the Gerbers, and finally you can make the prototype. Okay, before to go to the services, I will just make a quick review of the technology, what is a virtual antenna and which products we are offering to our customers. Just a quick review, probably some of you have been in the first WebTech, but I will go quickly on that. The virtual antenna is a new technology with a new generation of chip antennas, what we call antenna boosters. So the antenna, it is not the element itself. The antenna is part of the radiating system, and in this case is composed, as you can see here, by the booster, the matching network, RF module, and the PCB size. So the performance of the antenna is depending on the PCB size. And the radiating element, it is not the antenna itself, like other technologies. It is the whole system. So the antenna is, for us, not an element anymore. It's not a component anymore. It's a system. To work properly, we are always recommending to put the antenna perpendicular to the longest size of the PCB, because we are radiating through the PCB, not in the antenna element. It's the old PCB which is radiating, are the currents that are flowing through the ground plane, and these currents are radiating electromagnetic waves, and this is allowing the communication. The antenna booster needs to be located in appropriate corner with a clearance area, no copper in the different layers, a feeding line, a matching network, and RF module. Once you start with that, then you can place the other electronic components in both sizes of the PCB, but not before, because if the antenna cannot be located appropriately in a corner perpendicular to the longest size, then the performance will be affected drastically, okay? In our technology, we can use the same antenna for different platforms, as we shown here in this slide. And also the same antenna can attend different frequencies and different range, like NB-IoT, LoRa, GPS, Bluetooth, Zigbee. The thing is that thanks to this technology, we are adapting the antenna in the different platforms with the different frequencies, monoband or multiband, just by changing the matching network. Some of you are already familiar with the matching network. If not, there is a slide at the end of the presentation where it's explained this concept. But in summary, it's just a composition of passive components where we are optimizing the antenna performance. Okay, so it is just a trick to integrate the antenna and to maximize their performance. The range of product we have is not extensive because we can use, as I mentioned here, the same antenna for different platforms, different devices, monoband or multiband, just by changing the matching network, okay? We have several options in terms of dimensions, length, width, heights, just for you to use it in your design. The same antenna, as I mentioned, can be used for different frequencies, but also you can change the antenna if you have any constraint in the height or in the width or in the length. Then we are offering to you different options. And also, even more, in some cases, we have modular antennas. Then you can choose in your design to use one modular antenna or two separate antennas. So we are always giving you flexibility in form factor and in number of antennas to be used in your design. So here you have some, brief summary of the what are the advantages of the virtual antenna. It's covering different frequencies, monoband or multiband, from LoRa, Sigfox, Zigbee, NB-IoT, LTM, GNSS, Wi-Fi, NB-IoT, the Cat-M1, everything it's possible from 600 megahertz up to 10 gigahertz, okay? The antenna must be tuned with a suitable matching network. So more frequencies, more passive components in the network. Please keep in mind that the antenna performance depends on the PCB area. Here you have a link where we're showing you an example where we are giving to you real measurements in a PCB where we are locating an antenna, and then if we change the PCB size, and of course we change the matching network, you will see that the values of the efficiency will drop drastically when the PCB is reduced to minimum sizes. Okay. Then you have an idea what is the performance you can achieve. Depending on the PCB size of your device, you can go to this application note and you will have a first estimation of the performance. And as I said, we are giving you several antenna form factors in volume and also in surface to be selected for your IT devices. If you have any constraint in mechanical or in electrical, then you have options to use that. It is different than other antenna suppliers that they open the catalog and they giving to you 200 options. Give me the frequency that you want to work with, and then I will give you the antenna. No. In this case, the frequency is selected by you. It's not given by the antenna. And additionally to that, remember that we have, in some cases, modular options, and you can, even in your design, if you want to combine LoRa and GPS, LoRa and Bluetooth, or cellular and GPS, depending on your design, you can even choose if you want to do it with one single antenna or with two antennas or with three antennas. It's up to you, because we are giving to you flexibility on that as well. Okay, having said that, this is a little introduction on technology and in products. We go to the services. So in our company, we are very aware of the customers. They need very good technology, very good components, but also they need some technical support to facilitate the integration on the IoT device. Okay, so we have divided our services in these 5 different services. I put it here in this graph, which is a kind of roadmap, and I will explain it to you in a minute. If you have any question, please let us know by email, as mentioned by Olivier. The services that we're offering to our customer are split in these 5 parts. The first part, it is a basic service where we are just making some design recommendations and some simulations in the customer PCB and with the antenna location and the antenna performance in a bare PCB. So PCB without components, without any element, mechanical, any cable, whatever, okay? So this is a very basic service. After that, if you are satisfied with the estimated ideal performance that you can get with this PCB area and with these frequencies of interest, then we can jump to the second service, which is make some simulations, including the elements that you are going to use, like batteries, ICs, LCDs, covers, cables, whatever. Okay, so we have made one step from a bare PCB to your PCB. Keep in mind that we are working with off-the-shelf antennas, but the service is customized to your product. So we are helping you to integrate one off-the-shelf antenna, SMT, in your product. That means that we are going to make simulations taking into account your elements, your devices, your components, batteries, etc. And this is a service that we are making simulations. You will get, you will see in the next slide, some orientation on the antenna location, topology of the matching network, bill of materials of the matching network, some estimation of the performance of the antenna in your device, taking into account all the elements. The next step is to go from simulation to real measurement. As you know, in antennas, in RF designs, this is very important to make the difference between simulation and real measurement, because there are losses in many parts of the circuit, in the design, like component and so on. So this is also another service that if you are satisfied with the simulations that you get in your device and you make prototypes, you can send to us these prototypes, and we are going to measure in our lab all the stuff to maximize the antenna performance, and we are going to give you the bill of materials in real measurement values. This is a very complex service, very complex exercise. And it's taking, for a monoband antenna, it takes about 3-4 weeks, and multiband antenna takes about 4 or 5 weeks. But you are getting a real matching network, a real bill of materials to maximize the antenna in your device. In some cases, some customers, they try to make the matching network and they have a solution and they are getting some bill of materials, but they don't know if this is the best possible. And we are offering to you to have the best possible. Okay, having said that, with the just a little reminder, a bar PCB with your components, so customized service, and then matching network service. In some cases, a part of the different elements in the PCB and enclosure and so on, some customers, they say, okay, I want to know what is the impact of my device in external elements like the human body, or if you are making an element that is going to be placed in a wall, I want to see the impact of the wood or the cement, concrete, or the I don't know, the metals or ceramics, plastics, whatever. So there is another service where we can make simulations taking into account of the influence of the external elements of the IoT device. As I said, the human body or wood or plastics or elements like cement, metals, and whatever. Okay, so this is another service that in some cases, some customers are requesting to us. And finally, we are offering also a service to prepare your device to pass a certification. So if we know what are the targets from the operators, like for instance, TRPs or TIS from the operators of in Europe, Vodafone, Deutsche Telekom, Telefonica, whatever, or in the States, Verizon or AT&T, we can prepare the device to pass the certification. Please, I want to emphasize that we are not making certifications. We are not a certification company. So we are helping the customer to pass the certification, to prepare the device, and then if you go to the certification lab or the certification house and you are not passing the certification in one of the bands, we are also helping you to balance the energy in the different bands, and we can take it out from one band which is extra and we put it in one band which is lacking the energy to pass the certification. So we have made this structure of the different services from a bar PCB through the PCB with elements simulation, PCB with elements measurement, influence of the external elements of the device, a human body, for instance, or wood or cement, and prepare the device for the certification. Okay, so if you have any question on here, please send it to Olivier. We will clarify later. I will go through these different services just to emphasize what are the difference and to make it clear to you. Okay. The first service is, remember, this is in a bar PCB, so it's just the location of the antenna in a PCB. And with this simple form in our website, here you have the link, if you let us know the PCB size of your device and which frequencies you want to work with, we are going to make an analysis in our lab, and we are going to make a report with the antenna selection, the antenna location, what is the recommended clearance area, the topology of the matching network. In some cases, if the quantities are important, we can make also some simulations to estimate what is the efficiency performance of the antenna. And with that, you can make the first analysis, the first feasibility analysis for your project. So before to invest any money in prototyping, before to invest any hour in research, just by submitting your basic data in our link page, in our website, we are going to offer to you, we come up with a report where you can make the first feasibility analysis. This is amazing. This is possible because our technology is very simple, and it is possible to be done just with a simple analysis and simple simulations. And then you can start to have an idea what is going to be the performance of your device, and what is going to be the structure of the design, the layout, where the antenna is located. And if you want to go further, then you can start to locate the other components like microprocessors, RF modules, memories, cables, capacitors, electronic ICs, whatever. Okay, so this is the basic service. The second service that we are offering, if you are satisfied with it, is okay, I want to know more. I want to know what is the performance of the antenna with the presence of other components like these microprocessors, modules, cables, and so on. So we go to the second service that we are calling the NNS 2.0, which is to make electromagnetic simulation in the IoT device with a PCB and antenna and the other components like the batteries, LCDs, metals, enclosures, covers, whatever. So with that information, if we receive, let's see, an step file or a 3D model with all of these elements and the gerbers of the PCB and so on, then we can make the antenna selection to optimize and placing the antenna in the appropriate place to maximize the performance. And we are starting to make some recommendations for the matching network, the topology, and bill of material. So we will make the design review. As I said, the antenna placement agreement, we can interact with the client to see what is your flexibility in the design, what are the options we have, what are the constraints. And then we can propose to you CAD design for the feeding line, the first matching network is the first approximation, and the arrangement on customer and PCB, including the mechanical 3D models. Okay, so this is a more complex, more complete exercise rather than to work with a bar PCB. So this is a complete device. So we are going to give to you the bill of materials. Also, if you are interested in the matching network, simulated, not measurement, but if you want to make a measurement also in the matching network, we can go to the matching network service, which is the next slide. Okay, so this is an option for you. The principle here is to offer you the possibility to know the performance of the antenna in your device, taking into account all the elements of your design. So you have more information to make a feasibility analysis to go further in the design. Keep in mind that this is always a simulation service. You don't need to spend any money, any time in research. This is something that we are giving to you for your facility, for your analysis before to go to prototyping. Okay. The other service that we offer is, first it was the simulation. Now we are offering the real measurements with the matching network service. The matching network service is a complex service. We need to receive from you a full device, a full prototype with 2 additional populated PCBs, because we are making some experiments in our lab. We are soldering, desoldering, and in some cases we are breaking the pads. Then we are making a setup in the device, in the PCB, and we are accessing to the antenna with a cable, and we are soldering an SMA connector to make measurements in our lab, in the vector network analyzer, and in our anechoic chamber. Okay. The access point to measure the antenna performance is located before the matching network. So we are optimizing the antenna, including the matching network. Everything is optimized in order to get a very robust and stable solution. Okay. And all the measurements are performed considering the availability mechanical parts, so populated PCB, the batteries, LCD, covers, etc., etc. In this case, we are taking into account the influence of all of the elements in the system in the antenna performance. And we are coming up with a report where we are showing to you what are the setup we have performed, the explanation and pictures. We are giving to you the topology of the matching network, the bill of material of the passive components with part numbers. Remember that those are not simulated, they are real measurement. And we always compare before and after what we receive in terms of BSWR and what are you receiving before and after the matching network, as I said. The efficiency measurements also before and after, and we are giving to you the radiation patterns in 3 cuts. This is enough in order to know what is the radiation in the 3 main axes. Remember that all of our antennas are omnidirectional, so you will get what is the radiation in the different plans, assuming that the antennas are omnidirectional. Okay, and we also make some last slide with summary, conclusion, and recommendation for next designs. Okay, this is remember, this is the matching network service with a real measurement. Okay. The other service is the consultancy on the antenna integration. Remember that if you want to integrate an antenna and you want to know also not only the performance of the antenna in your device, but what is the influence of other elements external to the device, like the human body or the wall, the wood, the ceramic or metal, concrete, cement, whatever. Okay, so we can do exactly the same. We can make these kind of simulations in terms of consultancy in order to know for you what is going to be the performance of the antenna in your device and the impact of the external elements. The same we are going to do is to make some simulations, and we will come up with a report where you will see the antenna location, the topology of the matching network, the first approximation of the bill of materials, and what is going to be the performance of the antenna in this environment. Okay, and even if you want, you can compare in different environments. For instance, in an alarm, they want to know what is the performance of the alarm in a wall, if it is wood or if it is with cement or concrete or another elements, okay, or metals around it. Okay, so this is something that we are performing simulations for you to avoid the the possibility to make prototypes without knowing what is going to be the performance of the final device, okay, or at least one estimation. And the final service that we are giving to our customers, we are offering, is to prepare the device for a certification. Remember that we are not making certification, we prepare the device for the certification. So in that cases, if you speak to some certification houses like DECRA, which is in Malaga, in south of Spain, and also in Taiwan, you can ask to them what are the targets of the different operators to pass a certification for your device. If we know that, we can prepare your device with a matching network, and we can, balance the different the energy in the different bands in order to prepare the device and to pass the certification. In case of any problem in the certification in any particular band, we always can receive the feedback from the design house, and we will optimize it, and we will take it into account in the matching network to consider that in some bands there is a lack of energy, and we are taking out from another bands, and we balance this energy in order to pass all the bands, to prepare all the bands to pass the certification. Okay. This is the explanation of the different services. I make a summary here where you can see what are the different services and what are the different information that you are getting in each particular service. I just reviewed the first one, which is the wireless fast track. You submit it in our website, and we just need to know what are the PCB dimensions and what are the frequencies of interest. Then we will make a design review. We will make the antenna selection. We will send you design recommendations. In some cases, we make some electromagnetic simulations in a bar PCB. This is depending on the quantity. And we make also a pre-evaluation main antenna parameters assessed in bar PCB for proof of concept validation. Okay. So you will get some guidance for antenna performance improvement in case of the customer expectations are not met. So we are start to make some reports and simulations, but we also start some interaction with the customer to know what are the needs of the customer and what are the future steps. Okay. In the second one is when I said, okay, we are coming from a bar PCB to a complete PCB with all the elements of the customer device, including the all the ICs, microprocessors, RF modules, mechanical elements, connectors, whatever. So we can make some analysis of this device if we receive the Gerbers and also the 3D model step files. We made the design review, and we will select the antenna, and we will send to you some design recommendations, and we can make also some electromagnetic simulations of full device, taking into account the batteries, the casing, other electronic components, and so on. And this is going to come up with a pre-evaluation with the main antenna parameters, considering the full devices. Okay, so you can see what are the BSWR, what are the estimated performance, these kind of things, and also a guidance for the antenna performance improvement in case of the customer explanations or expectations were not met. So that is also generating an interaction between us and the customer to know what can be improved. And a typical discussion is, okay, can you please move a little bit the battery? Can you please move this connector or whatever element to increase the antenna performance? This is the kind of discussion that we are getting in the conversation with our customers. If the customer is satisfied with the simulations, then we can move to a real measurement. So we receive a device in our lab, and as I explained it, we solder a cable to access to the antenna area plus the matching network. We put an SMA connector to measure the devices in our BNA for the impedance, the BSWR, and in our anechoic chamber for the efficiency. And we are optimizing both parameters. We minimize the impedance and we maximize the efficiency. That is the reason that we are offering to the customer the best solution possible. Not one, but we guarantee that is the best possible in order to get a robust and stable solution. Remember that in some cases, some customers, they make a matching network and they don't know if it is the best possible, it is not stable, and later in production, they are getting some performance in one production line number and another performance in another production line number. So it is important not only to find a solution, it is important to have a robust and a stable solution. Okay. Also, we are offering this this service to prepare the device for the certification. And we can make some analysis in the setup, the same way that we make it in the matching network service. We are making some measurements always in passive. Remember, we never make it in active. The antenna performance test, the antenna tuning, the antenna performance analysis, and then the antenna is, or the device is prepared for the certification process. And normally it passes. In case of any problem, we receive the feedback from the lab that is trying to implement the certification, and then we are modifying the matching network to balance the different energies and to achieve the different targets in the different frequency ranges. Okay, so this is about it, Olivier and other people. Let's see if there is any questions or any doubts. Yes. Okay.
Yes, there are. Thank you, Josep. Thank you for the presentation. Okay, so you have, before we start with the question, I did send you the link for the survey. So please, give us your feedback. Again, it's important for us.
Okay.
I have questions. So welcome. We have, David was asking the question, is the clearance area size related to the communication frequency?
Yes, always. There is a trade-off not only between the clearance area, but also in the ground plane area. There is a trade-off between the minimum clearance area requirement in order to maximize the communication. Okay, so this is something that we are helping to our customers. There are several application notes where we are showing the impact or the influence of the clearance area in the antenna efficiency. Okay.
Okay. And the clearance area is I should say parameters that you are giving based on the first fast track report.
Correct. We are giving that. You can see here in this slide where we are we come up with a report where you see the antenna location. This weight is the minimum clearance area requirement, and this is the PCB size that is given by the customer. Notice that we always locate the antenna perpendicular to the longest size, and we are recommending the feeding line, the matching network, and the location of the RF module. Okay, so all of these basic recommendations are given in the first analysis of the device, only in a bar PCB, not with the components of the other components.
Okay, good. Lou is asking the question, is saying that the external housing shall also play a role. Testing should be done in a complete housing. Is it it is also possible to use a metal housing?
In some cases, it is possible. Only take some precautions in the distance between the metal and the antenna location on the antenna PCB. So you cannot place the antenna on the metal. And we have some customers, some applications that we have found a solution. Always, if you put the metal a minimum 5 millimeters length or away of the antenna. Okay, so if you take this precaution, you can place the antenna with the PCB away of 5 millimeters minimum of the metal, then you can work with it. We also are preparing application notes where we are showing to the customers what is the performance in function of the length of the distance between the antenna and the metal element. It cannot be located on the metal element. It cannot. The antenna cannot be touching the element, the metal. But if you take some precaution, and we can discuss it in the initial interactions with our engineers, to put it away minimum 5 millimeters, then this is working.
Okay, thank you. Julien is asking the question, which CAD software do you use for the simulation?
We are using a CST.
Okay. This is for the input information. Okay. Afed is asking the question, matching circuit could resolve the S11, but what about the other performance like efficiencies?
When we make the matching network exercise, always in a passive mode, we are always giving to the customer a report where we are minimizing the BSWR with the S11 parameter, as he mentioned. But remember that we are making the exercise in two vectors. One vector is the S11, and the other vector is the efficiency. Other suppliers, other companies, they are making the matching network always only with the S11. And we notice that by doing that, this is not the best solution possible because there are many losses in the components. So we are doing in two aspects. First, to minimize the impedance with the optimization of the return loss, the S11, and on the other hand, to maximize the efficiency, taking into account all the losses in the system, including the losses of the components of the matching network.
Okay, so Afed, I hope we answer your questions. Francois, sorry, no, it's not one. Mathieu is asking the question, what about the radiation directivities?
We are always working with omnidirectional antennas. So if you need a directive antenna, we can not support with our antennas, which are omnidirectional. In some cases, we can modify a little bit the radiation pattern with the matching network, a little bit, but not much. We try to maximize the radiation in all the directions.
Okay. Julien is asking the question, what is the rough order of magnitude for the NRE cost for the NN-S-XX, so the other services? The NS and S 2.0, 2.1, and 3.0?
Okay, the rough order of magnitude, this is always depending on the complexity of the request of the customer, but on average, you can estimate that the 2.0 is about 1,000 euro. The 2.1 for monoband antenna is 3,000 euro, and for multiband antenna is 4,500 euro. And in the 3.0, it's fully depending on the request of the customer, but can be similar to the matching network service, which is about 5,000 euro. Okay.
Okay. One question from Julien is, could you share some example of antenna performance achieved, for example, in 868 megahertz, 3D radiation power view, and antenna gain, this type of parameters? Do you have that?
Yes, I have it. I can show it in, let's see if I can go to my, let's see, website. Do you see my screen?
Yes, we do.
Okay. So we have many application nodes, but if you go to products, and one of our most popular antennas is this one, the 224. You go here, then you scroll down. There is one application node which is some experiments in clearance length and ground plane. Okay, so you click in this application node, and we are giving to you, in this case, what is the influence of the clearance area if we fix the PCB area and we change the clearance area. You have here a table where you can have the influence of the different clearance area in the low frequency range, for instance, 824, 960, that's an example. The efficiency is dropping from 73 to 58 if we are reducing the clearance area from 60 to 20 millimeters. It's not much, but it's showing through the influence, okay? The result. The other experiment that we have performed in our lab is to maintain the clearance area constant and to change the PCB area. This is more critical because the influence of the PCB length is affecting a lot the the antenna performance. Remember that every time that we change any parameter, we have to modify the matching network to optimize the antenna performance. Then when we make this table, if you are asking me 868, you can use this as an order of magnitude. The width of the antenna of the PCB is always 60. Then here is 120 by 60 up to 40 by 60. Then the average efficiency is dropping from 73 to 23. Okay, so this is a very nice tool because if you are working in a new design and you need a performance more than 30, 35% or 40%, and you need to pass a certification of 40%, you cannot work in a PCB size below 65 by 60. Remember that those are ideal cases, and there is a dropping some points where the efficiency is dropping from one ideal case to a real case. Okay, so this is giving you a guidance to start to work with PCB size if you want to obtain some appropriate efficiency in this frequency range. Okay.
Okay, thank you. There is a last question about the pricing on the antenna, and I can probably answer that.
Okay.
So from Mathieu. So Mathieu, you can. The price is very transparent, and as a starting point, one of the distributor RFPD, Richardson RFPD, you can go directly to the website and you will see the different price point in volume that give you an indications. Richardson RFPD is one of the largest in terms of volume for Fractus, so the pricing is close to the reality, and it can get some some good feedback. Oh, I missed two questions. Sorry, Lucy. Let me find them. Where are they? I can't see them. Let me go back.
Just let me make one important comment.
Okay, please.
Any additional question, please send to Olivier an email and we will respond by email. Okay, so I don't want to have any pending question to be answered.
Yeah, I'm sorry. I'm just looking. Okay, thank you, Lucy. So we did ask the question of the clearance area related to the frequency, and we did mention that. So maybe you didn't, got the answers. So yes, there is a related, a relation, between the clearance area and the performance of the device. It's very key, and you can see that what Josep is showing is part of the application notes. And there is also the external housing, play a role, of course. And Josep answered that yes, you can in some case have a metal house, but we will if you have a specific question, please feel free, send us the questions and we will address it. We are here to answer that. I have a last question. Which is not part of it. Josep, you are showing only one feeding, link to the booster from the antenna, or in the matching network.
Yes.
But when you have a multi-frequency application, which is a good case for this type of booster, can you have multi-feeding feeding link to the antenna, assuming that you have several several antenna in one, or how do you address a multi-frequency frequency booster?
The multi-frequency, if it is in the normal standard communications, 2G, 3G, cellular, LoRa, we are managing only with one feeding line, but the complexity of the matching network is huge. It's more complex. So the more frequencies to attend, more components in the matching network. Another thing is the modular solution. We have also modular solutions like this one in Trio, where we can attend different frequencies. For instance, in that case, it's going to be the same antenna for cellular and for GPS, okay? So here you have the model antenna where we have one feeding line for cellular and another feeding line for GPS. So this is the solution that we are offering in this case, and we have other cases like if you want to work with GPS and Bluetooth. This is the new antenna. This is Duo. You can go here in the user manual, for instance, where you can see this solution, where in the evaluation board, the antenna is located here, and we have two ports, one for GNSS, another one for Bluetooth. As I said, we have flexibility, not only in the way to select the frequencies to work with, but also in the number of antennas that we can recommend to you. In some cases, we can recommend one antenna for these two frequencies, for instance, GNSS and Bluetooth. But if you say, okay, I need to maximize the efficiency in GPS, then we recommend it to make one single antenna for GPS, because always when you are working with a combo antenna or with a modular antenna, you always pay a price in efficiency. It's depending on your requirements, and we can recommend to you one option or another option in function of your inputs.
Okay, that's good. Very good. Okay, so I think this is concluding the number of questions. Again, in about 24 hours, the link of this session will be available, so you can stream and review it, replay it, and you will also receive or be able, to download the presentation in 24 hours from now. Any questions, please don't hesitate, send us an email, and we will be pleased to answer it. Again, don't hesitate as well if you have a project to use the fast track, services, because this is going to give you, a fast idea and a quick idea, I should say, of what you can design. Thank you very much.
Olivier,
for your time.
Olivier, one last comment. In the presentation, I add some backup slides here where you can see some video tutorials in our website, do it yourself, an explanation of the concept of matching network, and also we have collaboration with some software companies like Cadence, where they have incorporated our antennas in their libraries, and then you can make the schematic, taking into account the antenna as an electronic component. You can download it in your schematic, and you can make and run and have a first bill of materials of the matching network.
Okay, thank you, Josep. Thank you to all of you for your attendance, and I wish you a good day and stay safe, please.
Thank you very much.
Thank you very much.
Bye-bye.
Bye-bye.
Bye.